When you talk about introduction to physics, for every topic, not just a science subject, for anything that he wants to get into, it's always very important. It's always very important to understand that particular thing so that you can be able to tell the story about it and then make relevant contribution whenever they are talking about that thing. And if you remember, when we start this class, the first thing we did is to introduce ourselves. Trying to introduce myself
Yeah.
to you is for you to be able to say something about me when anybody raised any comment. You know, when somebody make a statement, what they call statement is something that is arguable. I get it. A sentence that is arguable. That's what they call a statement. So if somebody say Mr. Toib is from Ibadan, you can easily make a contribution that no, he's from Osun State. He's only claiming to be from Ibadan. Somebody said, oh, he's yet to marry. You can say somebody that already got married and he has two kids already. You know, you can contribute, you can say something about him. And when somebody talk about Sami, I can also say that, oh, I know him, he's from Ondo State. For me to say that, oh, he's from so place, the person we have like is going to like set back and know that for this person to know his state, automatically he has idea of who some is. Are you getting where I'm coming from?
Yeah.
So exactly the reason why we need to introduce every subject. And introducing this subject shouldn't just be so abstract because there's a professor in physics, he's one of the best professor in physics, Professor Waterlewins. He's no longer lecturing any longer. So, and he said something. He said, if you are teaching physics and your class is boring, then you are a criminal. I repeat that statement. He said, if you are teaching physics and your class is boring, you are a criminal. Do you know what it means to be a criminal because his class is boring? Do you know what it means?
No.
For him to tell somebody that the person is a criminal just because his class is boring is to tell you how interesting that particular subject can be. This is very interesting, very, very interesting. But the problem we have is that we have large numbers of teachers that know it, they don't understand it. And there is difference between those two things. Know something and understand that thing. There is two different things. I can know you now. I might not understand you. And I'm still yet to understand you. You are yet to understand me. We only know each other. So there are some things that I'm going to say that are going to pick offense. If I understand you, I won't say that thing. Are you getting where I'm coming from now?
Yes.
So many teachers, they know physics. They know, a lot of people know physics, even than I do. But only few understand it. So when you now know something and you don't understand it, making it interesting will become difficult. And this is the first time you are like getting encountered with this topic. And that's why we have large numbers of people that create hatred for physics. That's why a lot of people think it's difficult. Absolutely, it's not. Because it's a subject that is not based on knowing. It is basically on understanding. It has nothing to do with you knowing it. Chemistry, biology. If you don't know chemistry, you don't know it. There's nothing you can do about it. Once you don't know it, you don't know it. It's not subject that has to do with understanding or anything. No, it's abstract completely. And then once you don't know any aspect of it, you don't know it. The same thing goes to biology. Anything that makes you not to know it, your understanding has nothing to play. Are you getting it, man? You can't go further. For physics, if you don't know it, for you understand physics, you can make a lot of contribution. You do well. So long you find interest in it, when they ask you question on it, you have something to say. That's why I want you to like open your mind and see this subject as something that is very simple. Are we together now?
Yes.
I welcome you to the class. And I'm going to start from how we start introducing ourselves the last time. I'm going to start from the name of the subject. That's physics. Look at this name. There's a joke that I always ask my students, and I fail to ask you. Do you ask your mommy why they name you Sonny?
Mm, yes.
You asked that, right? And
Yes.
what was her response?
She said he had a meaning.
Okay,
He had
and
a good meaning.
it has a good meaning. Okay, and you don't ask probably a reason behind like picking interest in that, because it's not only something that has meaning. There are a lot of names that have meaning, good meanings. Why that particular Tommy?
Don't know.
You don't know, or you don't ask to that extent.
No, I didn't ask to that extent.
I think you need to. There's always something. Whenever you want to know something or understand something, always try to know it to the deepest. And when will you stop knowing something? You stop when the person you are asking gets to the point that he or she cannot answer, and he return it back to God. That's when you stop. Because there are some questions like that that when you start asking, the person you always have answer to give you until the person gets to a point whereby the person has to refer it back to God. And I'll give you a very good example. Let's take for instance that you give me a cake now. I get it now, and
Yeah.
you can tell, because you're a scientist, you can tell me the quantity of sugar in that cake. You can tell me the quantity of salt. You can tell me the flavor you use in that cake. You can tell me a lot of things about the cake. But you cannot tell me why it is cake. If I say, why are they calling it cake? Okay, you can come up with
Mm.
a fabricated answer like, because they bake it, because that's what they are calling it. Why are they calling it like that? You know, we have gotten to a point whereby you need to leave me with my question. So at that point, you've known enough. So the same thing goes to when we talk about physics. Physics is the name, but why do they give it that particular name? The main reason why we give physics physics is because it is everything about the universe. It is what? Everything about the universe.
That's
Anything
what
you
it
want to
is.
talk about in universe, anything about universe you want to talk about, it is physics. Are we together?
Yes.
And that's why they gave that particular name physics, because physics is from the root word, a Greek word called physika. Either.
Yes.
So this is the background, the root cause of physics. This is it, from a Greek word called physika. And what's the meaning of physika, if I may ask? Or you are hearing it for the first time?
Yes.
Wow. Okay, but like what I told you earlier, that physics, it is everything about the universe. What can you now say physika will be?
Mm. The physical things around us.
Okay, things around us. Fine. I love that answer. Very brilliant. You know, you start coming up. There's something I want to tell you. When anybody asks you a question, see, don't make the mistake of saying what is in that person's mind, because you can never get what is in that person's mind. But feel free to say what you feel about that thing. Because you answer a lot of questions you don't prepare for on a daily basis. So, and you are able to answer that question only by saying your opinion. So when anybody asks you a question, just tell the person your opinion. So look at this now. Your opinion means, if I want to translate what you've said now to something else, I'll call it nature. Everything around us is nature. Do you agree with me?
Yes.
So if everything around us is nature, then physical should be nature. Are you getting this now? So the meaning of physical simply means the knowledge of nature. Have you seen it now? You've not known the meaning of physical before, but you're able to tell us what it is now. So physical simply means knowledge of nature. So when you now talk about physics, you are talking about what? Nature. Are you getting it now? I believe you are getting to know what physics simply means now.
Yes.
Now, I want to clear something about the definition that you have in your book. And I want you to be the lord of this subject. I want you to understand it, that when somebody is telling you something else, you can contribute very well. If you look at the definition that you have inside your textbook or your notebook, the definition states that physics can be defined as the study of matter and energy. If I'm not mistaken, that's why it should be in your note. Like if they ask you what is physics, you can say physics is defined as the study of matter and energy. That's basically what you are going to have in your book. But the question now is that definition really helping us? Because if you look at that definition, that physics is the study of matter in relation with energy. If you look at that definition, the definition has really thrown away the real meaning of physics. It's not really letting us know what is the importance of physics. It does not know it. Like with that definition, we cannot really tell how important it is. It's just like when somebody asks you, what is temperature? I'm asking now, what is temperature?
It is just like talking about heat or cold.
Talking about heat or cold, absolutely. And that's why, when they define it, they'll say temperature is the degree of hotness or coldness of a body. Abi?
Yes.
Yeah, the degree of hotness or coldness of a body. That's what they call temperature for us. But if you look at that definition, the definition does not really make temperature appear as something important. That definition throws away the importance of temperature, the degree of hotness or coldness of a body. It throws away the importance of temperature. But listen to this definition for temperature. And you tell me which one really lets temperature appear as something important between the two definitions. Are you listening?
Yes.
Okay. Temperature is defined as the property of an object that determines which way it will flow when the body comes in contact with another body. I'll take the definition again. Temperature is the property of an object that determines which way it will flow when the body comes in contact with another body. So which of the two definitions really shows importance of temperature?
The second.
The second one, right? The same thing,
Yes.
the same thing goes to the definition of physics. By defining physics as just the study of matter and energy does not really let you understand how important it is. Because that definition already throw away the meaning of physics. Now we're going to define it the way it's supposed to be now. Are you getting this now? We are going to do what?
Yes.
Define it the way it's supposed to be. But before then, take that. Let's take that. Let's summarize the whole of the story I've been saying together since morning as a note. Right. Physics comes from Greek word, physika. In quote, physika. Physics comes from the Greek word, physika. Which means knowledge of nature. Which means knowledge of nature.
Yes.
And its aim to analyze and understand, and its aim to analyze and understand, and its aim to analyze and understand the natural phenomena of the universe. The natural phenomena of the universe. Full stop. Do you understand that now?
Yes.
So I just use that paragraph to summarize the whole of the story we have said about physics since morning. So when you look at physics, it is from the Greek word called physika. What is physika? It is the knowledge of what? Nature. You having knowledge of nature, what is it going to enable you to do? It will enable you to analyze. It will enable you to understand how things happen the way they happened. Why is it that when the day break, what makes us know that the day has break is when everywhere is white? What brings about the white light? All of those things, they are natural phenomena. Those things happen naturally. Once you don't see the sun outside again, what you are going to see is what? Darkness. And that's why you get to ask yourself, does darkness really exist? You can ask that question. Does darkness really exist? And the answer is no, darkness does not exist. There's nothing like darkness. Because in your house, even if it is dark and you put on gen, you won't have that feeling that yes, it is night, except you want to sleep. Because everywhere will be white, like everywhere will be well illuminated. Are you getting where I'm coming from now? So darkness does not exist. And that's why in physics we don't study darkness, we study light. Because we know that everything that makes light to be absent, then darkness is going to surface. And if we want to continue having what? Light, we need to do what? We need to take away what? Darkness. What is that thing that can enable us to take away darkness? Is to have what? Light to be constant. And that's why in physics we study light, not darkness. The same thing goes to this statement. Coldness does not exist. Cold does not exist. It is absence of heat that brings about cold. And that's why in physics we don't study cold, we study what? Heat. Are you getting this now?
Yes.
So analyzing and understanding all these natural things is what makes this subject look so interesting, and that is all about physics. You think something that happens, you ask yourself, why is it happening like that? Why not like this? Analyzing it, then you come to understand it. That is what we call physics. Now let us now take the right definition of it now. Take that. Take the definition of physics now. Physics is defined. Physics is defined as a natural science. Physics is defined as a natural science that describes and explains the physical nature of science and universe. That describe and explain the physical nature of science and universe. Are you there?
Yes.
Now, I want to break that definition down for you now so that you understand why we said it has to do with describing and explaining the physical nature of science and the universe. What is even science and what is universe itself? You see, everything that we call what science, anything that scientists say they are doing, they are only revolving around what we call matter. And that's why anything that exists in life is matter. Anything that exists is what? Matter. Because from definition of matter, we have that matter is what? Is anything that has mass and that can occupy space. Anything that has mass that can occupy space is what we refer to as matter, isn't it?
Yes.
Now, can you give me an example of something that exists that does not occupy space?
Mm, Nothing.
Nothing. Nothing. Did you just say nothing?
Not. Yes.
Are you sure there's nothing that exists that doesn't occupy space?
A.
Air. Did you just say air?
Yes.
Okay, air does not occupy space, right?
Yes.
Okay, what about the one inside the, what's it called, the wheel of the car? What about the one you have inside your ball? Those ones are not air.
Yeah.
They occupy space. So long that they exist, they occupy space. Is there anything that exists that does not have mass?
No.
There's nothing. Think deeply. Is there anything that exists that does not have mass?
No.
Absolutely no. Anything that exists must have what? Mass. And anything that has mass must occupy what? Space. And look at this statement. There's a particular scientist called Hawkins. Hawkins is what's it called? What's it called? Is a Dutch physicist. There is a postulate about light by God's grace. When you get to SS2 third term, you are going to like get familiar with light wave very well. Light wave. Light wave is an example of an electromagnetic wave. But before they discover light wave, they already discover what we refer to as mechanical wave. Before they discover electromagnetic wave, they've discovered mechanical wave. Now, for mechanical wave, they always require what we refer to as material medium before they can propagate. For example, you cannot hear me if there is absence of air. Or can you hear me if there is no air?
No.
So because sound is an example of mechanical wave, it requires material medium, which is air. And that's how you can hear me. So, but light, the question now is, what is now the material medium for light? Because the speed of light is so mighty that there's no speed that is greater than it. 3 times 10 raised to power 8 meter per second. This is a very great speed. Nothing has this speed. There's nothing that has a speed that is equivalent to this. And that is the speed of light. And anything that will be a material medium for this light must have what? A speed equivalent to this or greater than this. And there's nothing. So scientists, they find it difficult to agree that light does not have a material medium. They raise different arguments. So a scientist called Hawking is what's it called? Is a Dutch physicist. He now came up with a material medium for light, and he called the name of that material medium ether. He said ether is the material medium for light. You know, like I told you earlier in this class, I said whenever anybody asks you anything, just tell that person your opinion and defend your opinion why you said what you said. So if it has a meaning to them, they will accept it. It becomes a theory. If it does not have a meaning to them, they will let you understand why it is meaningless. Then you will also agree with them and move on with what is right. It's just like I asked you of a definition now, and I said you are wrong. It is your opinion. You should be able to ask me why are you wrong. Then I should be able to tell you why you are wrong. Then if that reason is enough to convince you, then you will agree that you are wrong. Then if I tell you that this is what is right, and I explain to you why it is right, then you will agree with me. Then it becomes what? The knowledge that you are going to stick to. So ask these scientists that what is the meaning of ether? Like what are the characteristics of ether? He said ether is invisible. You cannot see it. Are you following now? He said it is what?
Yes.
Invisible. Everybody agree with him that yes, something can exist and you are not going to see it. God exists and we are not seeing it. Your brain exists and we are not seeing it. Anything that makes you to see your brain, then you are no longer alive. But you know you have a brain, Abi?
Yes.
The same thing goes to air. Air exists, but we are not seeing it. So everybody agreed with him that yes, it's possible, this thing exists and is invisible. What other property can we have for this particular ether? Then instead, ether has zero momentum. When he said that ether has zero momentum, then it's questionable now. They want to disagree with him now that how can you say something that is moving has a zero momentum when it's not as if it does not exist? Are you listening to the arguments now?
Yes.
They were like asking him, when you say ether has zero momentum, and this thing is moving, because what is momentum? So that you understand me very well. Momentum is the product of mass and velocity. So when you say momentum, you are saying what? The product of mass and velocity. Now, this thing, anything that is moving, so long that that thing is changing its position with time, that thing has a velocity. Are you getting it now?
Yes.
And anything that exists must also have a mass, no matter how small the mass might be. Even if the mass is very small, to the extent that the value is 0.0000000, and the zero full this screen, and you now have one behind it, it still has mass. Are you getting it now? So he now said momentum is zero. So if mv is equal to 0, then m can either to be the 0 or v is the 0. Are you following me now?
Yes.
If we say that momentum is 0, then what it's saying is that mv is equal to 0. And anything that makes mv to be 0 is either m is the 0 or v is the 0. But we have proved it now that light is moving, so automatically v cannot be 0. Are you following? V cannot be 0. So it means that for v not to be 0, and we are convinced that v can never be 0, automatically it is m that is 0. And if m is 0, that means that that particular thing does not do exist. And how they are able to rule it out that ether does not exist. And that ends the argument. You understand that now?
Yes.
And so, you know, analyzing nature, trying to understand what it is a key. Don't really make physics interesting. Now, you now talk about scientists and you talk about nature. When you're talking about scientists, let me just say you are talking about matter. Are you following?
Yes.
When you are talking about universe, you are talking about radiation. Are you following me now?
Yes.
So when you talk anything about physics, is either you are talking about matter or you are talking about what? Radiation. And that is the reason for the definition that you have in your book or your textbooks, that physics is the study of matter and energy, or the study of matter in relation with energy. Because when you are talking about the kind of energy they are pointing to in that place, they are talking about radiations. Have you seen the reason why they gave you that definition now?
Yes.
You can see that the definition is just summary of what we called physics. Can we go on now?
Yes.
So you have understand physics very well now. When we talk about physics, you can say a lot of things about it now. I'm asking, can you hear me?
Yes, I can.
So can you say something about physics very well now?
It's a natural science that describes the physical nature of science and the universe.
And the universe. So you can buttress more on that point. You know, that's just a straightforward point, just like what somebody have said, you just repeat it. Like if you want to buttress more on it, like the way I've been explaining that same thing since morning, you can do a lot of justice to that now, right?
Yes.
All right. Okay. Now, take down this paragraph. It's very important, right? Shall we?
Yes.
Note, the development of any nation, the development of any nation, the development of any nation depends on this subject called physics. The development of any nation depends on this subject called physics. Now, what will make this statement true? Listen, are you listening now?
Yes,
When
I am.
somebody says the development of any nation depends on physics, what are they talking about? You get to see that a lot of countries that are developed now, I'm not talking about underdeveloped country or developing country, developed country, what do you think that makes them develop? Like what are those things that we see them doing or that they have that make us conclude that this is a developed country?
First, a good economy,
Okay,
good citizens,
good economy, good citizens,
ability to make the right decisions at the right time,
ability to make the right decision at the right time,
and good leaders.
and good leaders. Okay, you know, every subject also have their own parts to come and play. So let's rule out the good citizens. Maybe government teacher will help us to take care of that. Let's rule out the good leader. I think government teacher should also help us to take care of that. What's it called? Good what again? Okay, let me just go to the one we want to take care of by ourselves, and that's good economy. When you say a country has a good economy, what are those things that define their economy?
Resources,
Resources,
people,
people,
that's it.
resources, people. Okay, let's leave. Okay, don't let me stretch it too much. What are the resources that we talk about?
Mm. Mineral resources like gold,
Gold,
diamond, crude oil.
crude oil. All right, don't let us stress ourselves too much. Let's pick those two only also. There are a lot of ones, but I just want you to be the one that will come up with everything. Let's pick those two. Is it possible for somebody to mine a gold or process a crude oil? What's that thing that will make it so easy for somebody to process crude oil or mine a gold with ease?
Mm. I don't know.
You know. You have been trying to, right now, what makes you say you don't know that you are trying to tell me the right thing? So don't try to tell me the right thing. Just tell me what you think that makes somebody get all of those things easily.
Get it processed easily.
Like the process, if you want to process it, what those things that you think that will make it so convenient, so easy to do?
Um, or gold if it's
So what?
we're able to if we're able to bring it out faster.
If you're able to bring it out faster, one.
And for crude oil, if we had something to make the processes easier.
Okay, add something to make the processes easier. Okay, it's okay.
Add
Don't
some
don't
add
stress yourself. I don't like stressing you. No, that one is enough. Like making it easy, making the process faster and easier. What do you think can now responsible for those things you've mentioned now?
are now responsible.
I'm not responsible. Is that what he said?
What do you say? Please can I repeat that?
Okay, I said, what are those things that can make what you just said now achievable? Like making it to be able to produce it very fast, to be able to produce it very easy. What's that thing that can make us achieve that? Okay, let me give you a clue so that you don't think faster or think too much. What's making it so easy for me and you to communicate now?
Yes, we can relate to each other.
Yeah, what's making it so easy for us to communicate now? You don't have to transport down to my side. I don't have to transport down to your side. And what we are supposed to do physically, we are doing it conveniently now.
Yes, internet.
Internet, what is internet?
Hmm?
Internet, what is internet?
Yes, like now Telegram, and we have Wi-Fi and we have gadgets that we can use.
All of those things are called what?
Electronics.
Electronics. Another name for electronics, like a compound name for all of those things. Sin is what you know. Like seriously, it's what you know that you have been saying it. You are saying it virtually every day. If I'm not mistaken, I dare to say you've said it today.
Uh,
That's just what technology. Do you hear that now?
yes.
Technology. If you look at all these developed country, you can see that their rate of the way they are technologically inclined is very on high side compared to developing country or underdeveloped country. It is technology that really make it easy for you to be able to mine gold with ease. Otherwise, you need large numbers of what's it called, manpower in order for you to be able to dig and dig and dig and dig before you can get to that point where you can find a gold or something. Are you getting this now? The same thing goes to crude oil. You need a certain what technology. If there's no technology, getting all of those things, refining it, all of that is not going to be what an easy process. And you're going to have that, but you're not going to be able to produce in abundance. If somebody asks you why in Nigeria today we are still suffering for light, it's as a result of technology. Because we don't have that capacity to buy tools that can enable us generate sufficient amount of energy that we need to survive a day. The tools that we have on ground that can produce the energy that is currently producing the amount we are using now does not have the capacity to produce large ones. The situation of the country we are, because we are not that technologically inclined, or let me even say we are not technologically inclined because we are just buying the ones we are using. We are not producing any. I think I'm coming from now. Eh?
Yes.
That is the major
Yes.
problem we have. That's why we cannot have sufficient light. But if there is what a particular tool that is sufficient to produce enough energy, the economy will not be the way it is. Because a lot of small scale business owners, they are the one contributing more to the economy of Nigeria than the big companies. But those small scale business owners, they need light to run their business. I always make a joke. I'll be like, Nigeria is the country where you'll be praying for God for safety. And at the same time, you'll be praying that you should meet light at home. You don't understand what I'm saying, Sonny. Sonny, you won't understand what I'm saying. But you know, somebody staying in the kind of environment I have, that they are not sure that they will all gel. Like currently now, I'm running this class with gel right now. If there's no gel, automatically it means this class will not be able to hold because like 3 days now, no light. So you're not in a situation where you are coming down to your house after praying that God, let me get home safely. By the time you get to your bus stop, you start praying that God will let there be light at home. You do all of those things because what? We are not that technologically inclined. And you can see that the rate at which people depend on NEPA reduce when we get to know about solar panels. Most people now buy solar panel, they use inverter just as a backup now. So, and when you talk about this technology, who are those behind the technology? We'll talk about the engineers. Are you following?
Yes.
We'll talk about what? The engineers. And all of those engineers, anything they are doing physics. If you are an engineering student, you do more of physics. Even to the point where when you hear somebody saying, I went to school to study chemical engineer, you thought probably the person will do more of chemistry, isn't it?
Yes.
But I dare to tell you now that the person will only do chemistry in first year and second year. That's the end of chemistry. Till the person will finish that course after 5 years, he's going to do more of physics. That's how important it is. And you know the problem about this thing? Once you've gotten it wrong from the foundation like this, by the time the building gets to the what decking or the roof, there will be a problem. You understand that now?
Yes.
All right now. So let me quickly give you some paragraph that will really help in terms of the calculation part of physics, because there's no way you are going to be studying physics that you are not going to calculate. And that is where students like their problems start from, because they don't know about how to go about calculating calculation in physics. So let's take that. It is very important. Are you taking it down now? It is very important.
Yes.
It's very important for anyone learning physics. It's very important for anyone learning physics to be able to solve physics problems. It's important for anyone learning physics to be able to solve physics problems which illustrate the applications of the subject accurately. Which illustrate the applications of the subject accurately, because that is the only way, to guarantee the understanding of the basic, physical phenomena out there of the subject.
Yes.
The chart below illustrates the guide for problem solving in physics. The chart below illustrates the guide for problem solving in physics. Now, I want you to pay attention to this graph now. I want to explain the graph to you. Whenever you are given a problem in physics to solve, are you following me?
Yes.
Once they ask you to solve a problem in physics, the first thing you should do is that read the problem. That's the first thing. And this reading is divided into two. Are we together?
Yes.
This reading is divided into two. The first reading, you are going to read it twice. When you read the question the first time, you want to get the idea of what the question is talking about. Are you following? Then you will now
Yes.
read the question again the second time. When you are reading the second time, you want to write out the parameters given to you in the question. For you to understand what I'm saying, let me give you an example. Let's say a car traveling with a speed of 100 meters per second out there, and cover
Yes.
a distance of 50 meters in 0.5 seconds. Calculate the acceleration. Of the car. This is just a random question that I want to use to explain what we refer to as reading. So, when somebody give you this question, the first thing you want to do is to do what? Read. You say what? A car traveling with a speed of 100 meters per second and cover a distance of 50 meters in 0.5 seconds. Calculate the acceleration of the car. This first reading, from this first reading now, we understand that what they ask us to calculate is what?
Acceleration.
Acceleration. So you already have idea of what you are calculating for. That's the first reading. Then you now read it again the second time. A car traveling with a speed of 100 meters per second. The car is traveling with a speed of 100 meters per second. You write it down. That is what? The initial velocity. Are you following now? That is velocity in which the car is moving. And cover a distance of 50 meters. Oh, distance is what? 50 meters. You can see the second reading we are doing, we are interpreting. In 0.5 seconds, oh, the time is 0.5 seconds. Calculate the acceleration of the car. It means we are looking for acceleration. Have you seen that now?
Yes.
So the first thing you do is to read. Read the first time to understand what the question is talking about. Read the second time for you to interpret the question by writing out the things given in the question. Are you getting this now? So let's quickly let's clean the board. We have been able to explain the first one now. What's now the second thing to do? When you are given a question, the second thing to do is for you to draw a diagram. Draw diagram. Now, why drawing diagram? Oh, the first question, not all questions require diagram. Are you with me? Not all questions require diagram. But let me quickly cast a question that might require diagram. Let's say a man moved from point A to point B to point B 3 kilometers due south. Are you following? A man moved from point A to point B 3 kilometers due south. And then move 4 kilometers to point C due east. Calculate the displacement. Calculate the displacement of the man. Calculate the displacement of the man. Now, if you look at this question, let's apply the first principle. What's the first principle? When we want to solve a question, we read. So let's read the question to ourselves. A man moved from point A to point B 3 kilometers due south and then move 4 kilometers to point C due east. Calculate the displacement of the man. What are they asking us to look for in this question?
Displacement.
We are looking for displacement. Now, the second reading. What are we going to do in the second reading?
To interpret it.
To interpret it. Thank you. So a man moved from point A to point B 3 kilometers due south. So that's distance. So 3 kilometers due south. Okay. And then move 4 kilometers to point C due east. Okay. So another distance is given there. Let's say this is S1, this is S2, and that is 4 kilometers. Calculate the displacement of the man. We are looking for displacement. Now, Somi, it is very difficult for us to answer this question right now. Because when they say displacement, I want you to understand this. There is difference between distance and displacement. When somebody say calculate the distance, distance is the total path traveled. Total path traveled, that is distance. But displacement is the shortest distance traveled. Are you following?
Yes.
So the question now is, we have gotten the whole of the distance that the man trek. The man trek 3 kilometer, he trek another what? 3 kilometer, another 4 kilometer. Abi?
Yes.
So the total kilometer the man trek is how many?
7.
7. So if it is the distance that they ask us to calculate now, there's no point in withdrawing any diagram. We can easily say it is 3 plus what? 4. But what they are asking us to calculate now, shortest distance. How do we know the shortest distance traveled? For us to be able to know the shortest distance traveled, we need to draw a diagram. Are you following me?
Yes.
So this kind of a question now requires to draw a diagram. So let's draw the diagram now. They say that the man moves from point A to point B. So this is point B here. 4 kilometers distance. So it means it's moving it downward like this. So that's 3 kilometers, Abi?
Yes.
And then move to point what? Point C, due east. So this is what? East. Am I right? You know, when we draw our cardinal points, this is north, this is south, this is east, and this is west. Okay, so I'm right. This is point C, 4 kilometers. Now, the man is coming to point C. Oh, I want you to understand, because I want you to determine what should be the shortest distance now. The man is coming from point A and is coming to point C. But he now walks such that he first of all gets to point B before he now moves to point C. What should be, instead of walking like that, what other shortest distance can he pass?
You can go diagonally.
He can go diagonally, right?
Yes.
That is, he should just move from point A down to point C. That is very short compared to moving from point A to point B then to point C. Now, let's see if it is actually short. You know, if it should move like this, it's going to cover a distance of 7 kilometers, Abi? But if it should move like this, we said it's short. Let's see if it is actually short. Let's say this is D. Using Pythagoras theorem, we have D square equals 3 square plus 4 square. So D square equals 25, and D is square root of 25, so D is equal to 5 kilometers. You can see it's actually what? Actually short. Do you understand that now? You see, we are only able to solve this question accurately because we draw what? A diagram. So, the next thing after you read a problem is for you to do what? Draw a diagram. So after you draw a diagram, what's the next thing? The next thing is to visualize what happened. The next thing is to do what? Visualize what happened. So let's take this down. The next thing, visualize. Visualize what happened. Are you following?
Yes.
And you will agree with me that we also visualize. You can see, the moment you look at the diagram, the next thing we look at is that, okay, if the man move like this and then like this, what's the shortest distance? We visualize it and we see that it should have just moved like this. That's visualizing. We visualize, we look at the diagram, then we are able to come up with what we are looking for. So what's the next thing? The next thing after you visualize is what? Identify physics principle. I want to say you should identify what physics principle that bind what you say. That what theory can you use to answer that particular question? After you visualize it, you've seen what happened. What physics theory can help you out? And you will agree with me, we also did that when we are solving this question. Abi?
Yes.
And what's that principle that we choose, that we identify?
We use the Pythagoras theorem.
Pythagoras theorem. We are able to identify what? The principle, Pythagoras theorem. So the next thing after you've identified the principle is to choose applicable equation. Choose applicable equation. Choose applicable equation. It can be one, it can be more than one. That's why let me just put the S in brackets. Yeah. Because at times you can have a single question and you are going to be having like 4 equations in order for you to solve it. Yeah. Choose applicable equation. And you see that we also did that when we are solving this question. We choose that the hypotenuse square is equal to the adjacent square plus the opposite square. You can see that's what we did after we have identified that it is Pythagoras principle. So what's the Pythagoras formula? We said it is hypotenuse square equal adjacent square plus opposite square. Do you get that now?
Yes.
Then what's the next thing after you what? Choose the applicable equation. The next thing you do is to solve the equation. Solve the equation. And you can see, after we pick the formula, we did what? We solved the equation. After we solve the equation, what do we do? I'm asking now. What's the thing we do after solving the equation? We got an answer. So we evaluate and check answer. Evaluate and check answer. And that's the chart for solving question in physics. Any question you want to solve. The only thing that will make you not be able to solve any question in physics is either you don't know how to read, or you don't know how to draw or when to draw, or you don't know how to visualize the diagram you drew, or you don't know how to identify the right physics principle, or you don't know how to choose the applicable equation, or you don't know how to solve after you know the equation, or you don't know how to write answer. So Sami, are you following me now?
Yes.
Whenever anybody is now trying to teach you anything that has to do with solving problem in physics, these are the things you should always watch out for on how to use them. Oh, read it, interpret it, draw the diagram. How can I draw the diagram? You learn how to draw the diagram. How can I visualize? You learn how to visualize. How can you identify physics principle? You learn how to identify physics principle. How do you choose applicable equation? You learn how to choose applicable equation. How do you solve? You learn how to solve. How do you evaluate? You learn how to evaluate. So for you to know how to handle any physics problem, this is what you want to learn. So for every topic, you want to learn how to read them, you want to learn how to draw their diagram, you want to learn how to visualize them, you want to learn how to identify physics principles that bind them, you want to learn how to choose applicable equation, you want to learn how to solve and evaluate. Have you seen what you want to learn now?
Yes.
Do you understand it?
Yes.
Okay, take it down and let's move on to the next setting.
I've taken it down.
Okay, you've taken everything down, right?
Yes.
Okay, let's go neon this time around. All right. So let me clean the board. All right. So the next thing I want to look at now is the branches of physics. We want to look at the branches of physics. When you talk about branches of physics, physics has a lot of branches. a lot. About, if I'm not mistaken, the branches of physics is going to be very close to 12, if not more than. Are you following now?
Yes.
So I will only call and explain the ones I remember. Are you getting it now? But I think I should be able to give you up to 8, if I'm not mistaken. So the first branch of physics, is the mathematical physics. Mathematical physics. That's the first branch. Now, what do we do in mathematical physics? When we are talking about mathematical physics, what we do there is that we study various applications of mathematics with physics. That's what we do. How to apply mathematics to physics. You know, mathematics is language. It's language of science. So when you now study mathematical physics, you are learning how to apply mathematics to physics. So when you talk about vector and scalar, you are trying to apply mathematics to physics. When you talk about differential equation, you are trying to apply what? Mathematics to physics. When you talk about numeric analysis, you are trying to apply mathematics to physics. So when you talk about mathematical physics, we are applying mathematics to physics. Is it clear?
Yes.
Okay, so take something down there. Let me put that in statement now. Mathematical physics, put this column in front of it. Are you there?
Yes.
Here we study various applications of mathematics. Here we study various applications of mathematics with physics. Here we study various applications of mathematics with physics. For example, vector and scalar. Vector and scalar, comma, differential equation, comma, numeric analysis, or you call it computational maths. Numeric analysis, or you call it computational maths, etc. So, do you understand that?
Yes.
All right. So the second one is general property of matter. General properties of matter. General properties of matter. They call it GPM. General properties of matter. What we study under general properties of matter? When you say general properties of matter, what are those things we study? Almost the entire time that we are going to use in SS class, we do more of general properties of matter. Are you getting it now? Because
Yes.
that is where we study gravitational field. That is where we study elasticity. That is where we study motion. That is where we study surface tension. That is where we study matter itself. That is where we study molecules. That is where we study electric field, and so on like that. Do you understand that now? Under general properties of matter. Those are the things we study there. We study gravitational field, we study elasticity, we study surface tension, we study motion, we study force, we study circular motion, we study different sort of motions under general properties of matter. So take something down. In this branch of physics, we study about gravitational field. We studied about gravitational field, elasticity, surface tension, motion, momentum, Newton laws of motion, etc. Do you get that?
Yes.
Can we move on?
Yes.
The next branch of physics is heat and thermodynamics. Heat and thermodynamics. Thermodynamics. Heat and thermodynamics. Now, under this, we study what we refer to as condition of heat. That is, how a body conducts heat, how a body releases heat. Are you getting this now? How a body absorbs heat. How does the body transfer heat? We talked about kinetic theory of gas, Boyle's law, Charles' law, pressure law, general gas law, ideal gas law, Van der Waals equation. These are the things to study under what? Heat and thermodynamics. We talk about temperature and so on like that. So when you say heat and thermodynamics, those are the things we talk about. Carnot cycle, Carnot engine, all of those things are what we discuss under heat and thermodynamics. Do you understand that now?
Yes.
Now, take something down under it. Here, we study about kinetic theory of gases. Here, we studied about kinetic theory of gases, comma, conduction of heat, conduction of heat, heat and temperature,
Yes.
heat and temperature, and their relation to energy and work. And their relation to energy and work. And their relation to energy and work. So we have the next one. Optics. Optics. Are you there?
Yes.
Now, when you talk about optics, we are talking about studying the behavior of transparent materials. Materials that are transparent. How do you study how they behave? When you study them, you know their characteristics, you know their usage, such as lens, mirror, light. Now, these are things that we do under optics. You can even say optics is the study of light. Are you getting that now?
Yes.
So when you study optics, you are looking at the properties of light, and at the same time you are studying transparent objects. You know, when somebody is suffering for short-sightedness or long-sightedness, or what's it called, the old age of sight and the lights, all of those things are under the properties of light, because the only thing that affects you to see something that is far from you, the thing that affects you from seeing what is closer to you, the thing that affects you from not seeing clearly, probably because of old age and the like, is as a result of light that is having issue entering your eye. Because you will not be able to see anything. Tommy, do you see what is at the back? What's at your back now? Do you see what is at your back? Just face your system. Do you see anything that is at your back?
No.
Do you know the reason why you're not seeing that thing?
There isn't any like reflection from it.
That's just it. Any light that
That
is projecting from that object, like you said right now, is not entering your eye. That's why you cannot see it. It's not because you don't have eye at the back. Are you getting it now? Because if normal person want to answer, they say because you don't have eye at the back. But The moment you place mirror in front of you, are you still going to see what is behind you?
Yes.
By the time you place a big mirror in front of you, will you see what is behind you?
Yes.
That's because what? That mirror enables the light of that object to enter your eye. Do you get that now? So when we study
Yes.
all of those things is what we refer to as what? Optics. So take something down under it. Here we study the behavior and properties of light. Here we study the behavior and properties of light. Have you taken that down?
Yes.
And the next one is electromagnetism. 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 Now, when we talk about electromagnetism, we are talking about the interaction between electricity and magnetism. Are you following me now?
Yes.
When you talk about, when you hear anything electromagnetism, it is two words. You are having electricity, at the same time you are having what? Magnetism. Those are the two things that come together to form the word electromagnetism. So the interaction between electricity and magnetism is what we refer to as electromagnetism. Now, by the time you put on your gel, it brings about light, isn't it?
Yes.
And light is as a result of what? The continuous flowing of electrons. And continuous flowing of electrons in a conductor is what we refer to as what? Electricity. Are we making sense now?
Yes.
So that's what we refer to as electricity. Now, in your gel, what brings about that light is as a result of the coil that you have inside your gel. Are you getting it now? So
Yes.
you are converting magnetism to what? To electricity. The interaction between those two things is what we call electromagnetism. And that's why you hear people talking about dynamo and the like. Don't worry, it's a topic we are going to enjoy when we get there. Do you get that now?
Yes.
So take something down under it. Electromagnetism, which deals with the interaction of electric and magnetic fields, which deals with the interaction of electric and magnetic fields here we study about electromagnetic and we study about electromagnetic force. Here we study about electromagnetic force. Are you there?
Yes.
Which is one of the four forces that we have in physics. Which is one of the four forces that we have in physics. Now, what are those four forces we have in physics? Are you there?
Yes.
In physics, we have what we call contact force. We have magnetic force. We have magnetic force. We have electric force. And lastly, we have gravitational force. Gravitational force. So, electromagnetic force is one of those forces. Do you get that now?
Yes.
So the next one we want to talk about is another branch of physics is atomic and molecular physics. Atomic and molecular physics. Atomic and molecular physics. Are you there?
Yes.
So when you talk about atomic and molecular physics, we are talking about the basic building of matter. That is, when you talk about the basic building of matter, you are talking about atom. Are you getting me now?
Yes.
You are talking about what? Atom. So this is where we really study the properties of atom, electron, proton, neutron. We talk about everything about them under atomic and molecular physics. Do you understand that now?
Yes.
So take down. Here we study basic building blocks. Here we study basic building blocks of matter and their interactions. Of matter and their interactions. Here we study basic building blocks of matter and their interactions. Are you there?
Yes.
So the next one is nuclear physics. Nuclear physics. Now, when you talk about nuclear physics, this is where we study about the structure of atomic nuclei. When I say the structure of atomic nuclei, you know, for every atom, can I clean this?
Yes.
Okay. You know that for every atom, we have it like this. This is an atom. This atom has inside it what we call nucleus. Outside the atom, we have an electron. Inside the atom, we have nucleus that consists of proton and neutron. Proton, neutron, electron. Are you getting this now? Now,
Yes.
the aspect of physics that focuses on the study of this innermost part, that is this nucleus. The aspect of physics that focus on this inner one here, that talks about it, is what we refer to as nuclear physics. Are you getting that now? So when you talk about nuclear
Yes.
physics, you're talking about proton, you're talking about neutron. You want to talk about everything about the nucleus of an atom. You want to break it down. What are their properties? How do they behave on different conditions? That's what we do under nuclear physics. And you're going to have a taste of it when you get to SS3. When you're talking about duality of matter, you're talking about radioactivity, and so on like that. The postulate of Bohr postulate and the likes. Those are the things that we discuss under nuclear physics. Do you get that now?
Yes.
So take them. Here we study the behavior. Here we study the behavior and the structure of atomic nuclei. We study the behavior and the structure of atomic nuclei. That is proton, neutron, and electrons. That is proton, neutrons, and electrons. That is proton, neutrons, and electrons. You understand that now?
Yes.
Okay. So the next one that I want to talk about is condensed matter physics. Condensed, that's another branch of physics. Condensed matter physics. Condensed matter physics. Are we there?
Yes.
So what we do under this aspect of condensed matter physics is that we study rigid bodies. Everything under this aspect of physics is what? Everything about rigid body. Are you there now?
Yes.
So talk, write down now. Here we study rigid matters or solids. Here we studied rigid matters or solids. With the help of quantum mechanics, with the help of quantum mechanics, with the help of quantum mechanics. Are you there?
Yes.
Crystallography. Crystallography.
Crystallography.
Yeah, crystallography. Like Crystallography. Are you there? That is
Yes.
Raphy. Yeah, I think he's missing there. Raphy. Crystallography. And electromagnetism. And electromagnetism. And electromagnetism. Are you there?
Yes.
So the next one is relativity. Relativity. Are you there?
Yes.
Now, under relativity, what we do is this. What we study basically under relativity is that we are comparing the relationship between a body that is standing and the one that is moving. Are you getting me now? When you are standing
Yes.
and you are observing something that is moving, or when you are moving and something that is standing is observing you, or like when you are moving, you are studying something that is standing, or when you are standing, you are studying something that is moving. That's what we refer to as relativity. That's what we do there. Do you get that now?
Yes.
So here we discuss laws of physics. Here we discuss laws of physics. Laws of physics with the accelerating and non-accelerating observers. With the accelerating and non-accelerating observers. And this is very important for cosmology subjects. This is very important for cosmology subjects. Are you there?
Yes.
So the next thing there, which will be the last one, I think I've mentioned up to 8, right?
9.
Okay, let me just add this one to make it 10 then. So we have astrophysics. Astrophysics and cosmology. Astrophysics and cosmology. Now, under astrophysics and cosmology, this is where we study the evolution of the universe. Are we there? This is where we try
Yes.
to answer the questions such as, does God exist or God does not exist? When the universe starts existing, when is it going to collapse? All of those things. These are things we do under astrophysics and cosmology. It is abstract. Are you getting this now? But very interesting. Are you getting where I'm coming from now?
Yes.
But if you are a pastor or you are a far, you might probably feel this aspect of physics because there are a lot of things that is happening there that might go against your own belief. Do you understand where I'm coming from now?
Yes.
So take that. It involves the origin and evolution of the universe. It involves the origin and evolution of the universe. It is said to be the study of nature on a large scale. It's said to be the study of nature on a large scale. So that's that about the branches of physics. So the next one we want to look at after the branches of physics is the classes of physics. Classes of physics. You see all of these things that I've mentioned since. Classes of physics now, so then. You see all of these things that I've mentioned since about the branches of physics. You can only categorize them into two. You can do what?
Categorize them in groups.
So that's what we refer to as the classification of physics. So when you are classifying it, you can classify it as a classical. You can classify physics into two, right? Physics can be classified into two. Physics can be classified into two. How there?
Yes.
One, classical physics. Classical physics. How there?
Yes.
And two, modern physics. So those are the two categories of physics. All of those 10 to 20 or how many branches of physics that we have listed now, you can classify them into two. Classical physics, or you classify them as what? Modern physics. Now let's define classical physics and modern physics so that when you want to classify all of those things we've mentioned, you know how to classify them correctly. Are you there?
Yes.
So when you say classical physics is the study of motion of bodies. Classical physics is the study of motion of bodies under the influence of force. Under the influence of force. So any of those branches, are you there? Any of those branches
Yes.
that we have talked about that has to do with force and motion, you classify them as classical physics. Example include mechanics, heat, wave, light, sound, electricity, magnetism, and so on. Are you there?
Yes.
So those are what we refer to as classical physics. Then the next one, that's the modern physics. Modern physics. Are you there?
Yes.
So modern physics includes relativity. Modern physics includes relativity, nuclear physics, electronics, quantum physics, biophysics, astrophysics, condensed physics, and so on. All of those ones, they are modern physics. We have 9 minutes more, so let's be fast about that. You get that now?
Yes.
So the next aspect of physics that I want to talk about is the economic importance of physics. The economic importance of physics. That is how important it is. You know, we said it earlier when we start the class, when we are talking about the economy of a country. Physics plays a lot of role in that. So let's take some down, some of the importance. One, physics makes us understand nature. Physics makes us to understand nature. Physics makes us to understand nature. When you understand nature, you know what to sell. You know what to convert that will become what money. You know when to farm and when not to farm. Are you getting all of that now? So
Yes.
that's one. So two, discoveries in physics. Are you there? Discoveries in
Yes.
physics are applied in technologies that drive the economy of nations. That drive the economy of nations. Okay.
Yes.
The third one. Physics is an important element in the education of chemists, engineers, etc. Physics is an important element in the education of chemists, engineers, doctors, surgeons, and so on. Out there.
Yes.
Fourth one. Physics extends and enhance our understanding of other disciplines. Yeah. Physics extends and enhance. I think it should be enhances. Yeah, it should be enhances. Physics extends and enhances our understanding of other disciplines, such as the earth, the agricultural, the chemical, the biological, the environmental, and the science, etc. The sciences, etc. Okay.
Yes.
Last one. Physics improves our quality of life. Physics improve our quality of life by providing the basic understanding. Physics improves our quality of life by providing the basic understanding necessary for developing new instruments and techniques. Physics improves our quality of life by providing the basic understanding necessary for developing new instruments and techniques. So do you get that now?
New instruments.
New instruments and techniques.
Okay.
Okay, so the last part of the class is the physicists and their achievements in the field of physics. The physicists and their achievements in the field of physics. That's the subheading. Right. Who do we call a physicist? Right. The person, are you there?
Yes.
The person who study the nature, the person who study the nature and understand why things exist the way they are. The person who study the nature and understand why things exist the way they are is called a physicist. Is called a physicist. Is called a physicist. Are you there?
Yes.
So anybody that studied nature, that person understand why things exist the way they are. That person is called a physicist. Do you get that right now? And
Yes.
that's why they said anybody that study physics is called a physicist. Because if you say you study physics, then you must have understand why things exist the way they are, and you also understand nature. Is that
Oh,
taken
no, we are
now?
in a class. So we should have left us outside.
The door is open.
The door is open.
Yes.
Do you get that now?
Yeah.
All right. So that's about who we called a physicist. So we want to talk about some of them now. So some people always say physician. A physician is a doctor. Are you getting this now?
Yes.
Physician is a doctor. Physicist is somebody who study physics or somebody who has a better understanding of what life, how nature is. The person understands nature and why things exist the way they are. So paragraph now. Some great physicists and their achievements in the field of physics. Some great physicists and their achievements. Some great physicists and their achievements. Are you there?
Yes.
1. Galileo Galilei. I think I'm getting the spelling wrong. Galileo Galilei. Galileo Galileo Galilei. Are you there?
Yes.
He's an Italian physicist. He's an Italian physicist. This is from Italy. Are you there?
Yes.
And he's the father of modern experimental physics. He is the father of modern experimental physics. He was the first person to study motion. Are you there?
Yes.
He was the first person to study motion. I think that's fine about him. Number 2, Isaac Newton. Isaac Newton. Isaac Newton is from England. Isaac Newton is from England. Oh, there.
Yes.
And his achievement is that he's the first to separate white light into 7 colors. He was the first to separate white light into 7 colors. Oh, there.
Yes.
He stated the law of gravity. He stated the law of gravity. Oh, there.
Yes.
And he stated the famous 3 laws of motion. He stated the famous 3 laws of motion. Oh, there.
Yes.
He also stated the universal gravitational law. He also stated the universal gravitational law. So the third one we want to talk about is George Simon Ohm. George Simon Ohm. Are you there?
Yes.
He's from Germany. Ohm is from Germany. And stated the famous law called Ohm's law. Called Ohm's law. Okay.
Yes.
And the next one is Robert Hooke. The next one is Robert Hooke. Robert Hooke. Robert Hooke. He's from England. Are you there?
Yes.
Robert Hooke is from England, and he stated Hooke's law. He stated Hooke's law. He stated Hooke's law. And the next one, are we there?
Yes.
I think this is the fifth one, Abby.
Yes.
Okay. Benjamin Franklin. Benjamin Franklin. He's from America. He's from America. He's from America. Are you there?
Yes.
He invented the lightning conductor. He invented the lightning conductor. And he was the first person. He was the first person to use the word negative and positive charge. He was the first person to use the word negative and positive charge. He was the first person to use the word negative and positive charge. Are you there?
Yes.
So that's that about the introduction to physics. So, in a nutshell, we have been able to explain the concept of physics, that is, the root words of physics, and we said physics is from the word physica, that simply means what? The knowledge of nature. Abi?
Yes.
So, and we define physics as what's it called? As the pure science that has to do with the study of nature, how things exist the way they are, and it is also the backbone of all sciences or technologies out there now. We also talk about the development of any nation, how it depends on physics, and it is very important as somebody who is doing physics to know how to solve problems in physics. And we identify the steps in solving problem in physics, which the first one is read the problem, draw diagram, visualize, identify physics principle, list the data given to you, choose applicable equation, solve the equation, and check your answer. Then we talk about the branches of physics, and we also talk about the economy importance of physics, and we wrap it up with the great physicists and their achievements. I believe you understand this class clearly, right?
Yes.
Is there anything that you are still like finding difficult as far as physics introduction is concerned? Is there anything? Is there anything you don't understand from the class?
No.
All right, take down these assignments now. So you have to submit the assignment in our next physics class. Right there.
Yes.
Okay. As a student of science, as a student, that's number one. As a student of science, differentiate physics from other science subjects. Differentiate physics from other science subjects. Are you there?
Yes.
2. Explain 5 branches of physics with a detailed examples. Explain 5 branches of physics with a detailed examples. Are you there?
Yes.
Number 3, explain what is meant by the statement. Explain what is meant by the statement. Physics is the backbone. Physics is the backbone of technology. Are you there?
Yes.
Okay. So number 4, with the least form of ambiguity, the least form ambiguity, introduce physics to a layman. Okay. With the least form of ambiguity, introduce physics to a layman. All right, I think that's fine. So we'll stop here. I think it's a very good place for us to stop. So we'll meet in the next class. But it's